Let's talk about the entropy of vaporization of water. Now, water, we know, is special for many reasons, but the hydrogen bonding network is particularly important in water because the hydrogen bond in water is quite strong and actually can help limit the number of microstates in the liquid phase. Here I have two diagrams showing how water is slightly oriented even in the liquid phase due to the strength of the hydrogen bonding. My question for you is, how will that affect the entropy of vaporization for water versus other liquids? Most liquids, it's about 90 kilojoules per mole. For water, do you expect it to be about 90, greater than or less than 90 joules per Kelvin mole? Think about that for a minute and make a selection. Let's look at a possible explanation for every answer. A, the liquid is a relatively low entropy state, so the entropy of vaporization for water must be less than expected. B, entropy of vaporization for most liquids is about 90, so we'd expect that for water. And C, gases are similar. Water, though, has a more ordered liquid, so delta Ace of vaporization is greater than expected. Think about those three possible explanations and make a selection. We're talking about the entropy of vaporization of water. Most substances have an entropy of vaporization, that is their enthalpy of vaporization over their boiling point, of around 90 joules per Kelvin mole. Now, for water, because of the strength of the hydrogen bonding network, it has unusual order in the liquid state, so slightly more ordered than standard liquids. So when you're talking about a lower entropy in the liquid, the entropy of vaporization, which is the entropy of the gas, the final state, minus the entropy of the liquid, the initial state, this is actually smaller, a lower entropy in the case for water. So the entropy of vaporization will be slightly larger. The entropy of the gas is about the same. All the gases are particles spread out and not interacting. In the liquid phase, the interaction of the particles and the hydrogen bonding lowered the entropy of the liquid for water. So slightly lower number here means a slightly larger number for the entropy of vaporization. And that is true, the entropy of vaporization for water is more than 90 joules per Kelvin mole. Now, you may have been able to guess this for another reason. We've seen that the enthalpy of vaporization for water is around 40 kilojoules per mole. And you know water boils at around 400-ish Kelvin. So you could have done this math kind of in your head and come up with a fact that, well, that's closer to 100 joules per Kelvin mole than 90 joules per Kelvin mole. So two ways to approach this problem. In each case, you wind up with the same conclusion, that the entropy of vaporization for water is slightly higher than for other liquids.